Hello, welcome to another Teachertopian tutorial. We're going to be looking at trace tables from topic 1, the specifications 1.2.4 under Edexcel GCSE Computer Science, and we'll do an exam style question to make sure that we're comfortable with these ideas. So what is a trace table? A trace table is used to track values of a variable as a program or algorithm runs. Let's say during execution of program. Alright, so that's the general definition there, and we can use it to make sure that an algorithm is producing desired results before we maybe scale it or apply different data to it. So it's a useful thing to do for developers. So I think the best way to do this is to actually just go through an example. So let's have a look at this. Laura owns a fruit shop. This program checks the weight of boxes of strawberries from Laura's shop. Alright, so here we go. So we've got some variables here. Count equals 0, weight equals 0, all integers, and while our count is less than 4, we'll update the value of our count and look at the weight. So we're going to get the integer value from the user because it's an input statement, and if the weight is less than 395 or weight is greater than 405, so either one of those sides needs to be true in order for the whole statement to evaluate to true. Reject equals reject plus 1, so we will be adding a value to reject if that's the case, if that condition is met. Else accept equals 1. So we've got all of these, and we've got the values that were input from the user. Okay, so let's have a look. We've got the trace table on the right hand side, and we've got all our variables up here, so we can keep track of that. So we know at the beginning that count is 0, accept is 0, reject is 0, and weight is 0, and we've got nothing on display because the print statement hasn't got anything to display yet. So let's look at the first time the program is running. While count is less than 4, count equals count plus 1. So we're going to be adding 1 to our count. And the weight that was added in was 404. Now, if weight is less than 395 or greater than 405, interesting. So none of those are met with 404. So that conditional statement does not go through. So else accept equals accept plus 1. So we know we've got a 1 being added to accept there. And let's put the weight in because we know that was 404. That's what they typed in. So we've done the first one. The second time the while loop goes round, count is going up by 1 each time. So count equals 2 now. What was the weight? It was 393. And 393, is it less than 395? Yes, it is. So I don't even need to look at the right hand side. I know that that condition is met. So reject equals 1. So I've got 1 for a reject at that point. Count goes to 3. And at this stage, we've got 395 in there as the data type. Sorry, the data. And let's have a look. 395. If weight is less than 395, no, it's the same as 395, or weight is greater than 4. Okay, so again, that's lines 9 and 10 are not going to be applicable here. So we've got else instead. Except is already been updated to 1. So we're adding another 1 to that. So it's going to be 2. So except is going to be at the value of 2 now. Now let's go again. Now count at the moment is 3, and while count is less than 4, it is. So it is 3, so it will run. We do have count 4 to go through. And the last one is 405. And 405, again, it's greater than, but if it said greater than or equal to 405, then we would reject it. But in this case, it doesn't, it just says greater than, and it's not the same. So we're also accepting another one. So we've got accept 3 for that one, and we're done with the while loop. We're not running that anymore, because the next time this goes round, count is now equal 4, and this won't work. So we finally print accept and reject. So on the display, it will have the value for accept, which was 3. 3 were accepted, and 1 was rejected. That would be. I think that's the only possible way of answering this. So they would provide you this trace table in the exam, and it's a 6 marker. I think that's quite a nice 6 marker, actually. The only thing that could probably trip you up is having these less thans rather than less than or equal tos, and understanding that a while loop will just keep on going round until a condition, in this case count, as long as count is less than 4, it will keep on running. Okay, let's have a look at another question then, shall we? Another type of trace table. Here is an algorithm. My number is 0, and then same variable number, so for same variable name, we're getting input from the user, enter a whole number between 1 and 100, and that's going to convert it into an integer, which is what we need because it's a string, if they just typed in a number with a keyboard. And here we go. So if my number is less than 1, so right, so we've got different inputs from the user. That's helpful. So the first time round it goes to, this is an easier question, but it's still 4 marks. So what does 200 get to? So is it less than 1? No. Greater than 100? It is greater than 100. So it will look at this one first. It will look at this one first. And if 200 is less than 1, it would say too low, but it's not the case. And it's going to look now at the next else if. ELIF stands for else if. So because the number is greater than 100, it's going to say too high. It's not going to get to the second else if. You can have multiple if statements, and if these were multiple if statements, then yeah, you can have different outputs there. But in this case, it's if this is this, then do this, else if do this, else if do that, and it will just keep on going down. But as soon as one of those conditions is met, it will stop. So it's going to say too high for 200. How about 33? So it's going to look at this one and doesn't need to do anything with it. It's not greater than 100. Modulo 10 does equal 0. No, because it's not going to be even. And elif number is exactly the same as 100. No, it's not. And so we've exhausted all of these options. The else, the only one we can put in is good choice. Okay, that's the only one there, because all those options weren't valid for it. Now 100. Here, we're not going to get to this one because 100 modulo 100, sorry, 100 modulo 10 will equal 0. So it's going to stop there. It will say nice round number. And 0 is going to go, 0 is less than 1, so it's going to go too low. So I think that's not too bad, that question. The only tricky bit might be this 100. You might be considering, if the number does equal 100, that's the biggest number. Well, it's not going to get to that point, because if you remember what the modulo operator does, it will check the remainder of a division. So if we divide by 10 and we've got nothing remainder, which is applicable in this case, then it will say nice round number. All right, so hopefully that's going to be okay for trace tables. I think that's indicative of most exam style questions, as long as you'll be able to follow these algorithms. And the nice thing is they're not pseudocode, it's Python. You might see some pseudocode in paper 2, but luckily for paper 1 they're giving you essentially Python code there. So that's a bonus, I think. It's just easier for you to follow the logic of, because you've already been programming. Okay, if that helped, let me know. If you wanted me to do some more work on that, also let me know. And good luck.